Eric Archer here from TI, and today we're going to explore watersheds, erosion, and deforestation. So when it rains outside, where does that rain go? Like where does all that water go that accumulated on the ground from the rain? Obviously, it has to go somewhere. And if you live near a body of water, say a river or a stream or maybe near the ocean, that's likely your answer. So a watershed is an area of land that drains to a body of water. And so things like agriculture, deforestation, road building, and urban sprawl, these are human activities that change the amount of vegetation within a watershed, which again is the area of land between where precipitation falls, where water accumulates, and then the body of water that it drains to because of gravity. So with less vegetation, you typically have more erosion from water movement and wind that wears away the surface of the land. And so when scientists measure the quality of water, how good that water is, how clear it is, one of the things they measure is how cloudy it may be, and we call this turbidity. And turbidity usually means higher levels of erosion. So today we're going to explore the relationship between deforestation, erosion, turbidity of a body of water near an area of land, the watershed, how all that stuff works together, and in some cases, in most cases, in a negative kind of way. And so that's the activity for today. If you want to follow along, you can download this activity called Watersheds from our website at TI-Nspire.com. And to use that activity, you need the TI-Nspire CX Premium software, and you can find that at our website at education.ti.com. Okay, let's get started. Okay, so I've opened up the file Watersheds within the software. This is again the TI-Nspire CX Premium software, and the file is titled Watersheds. So you can find that under Earth Science on scienceinspire.com. And basically, we're just going to go page to page. There's a really nice simulation we're going to explore, and then we're going to talk about some questions, ask some questions, and explore some answers as a result of the interaction from the simulation. So page 1.2 is the first sort of question. Predict what will happen to the turbidity of a stream as the trees and vegetation along the banks are removed. So, again, if we take away the vegetation, it loosens up the soil of the land. And so erosion is sort of a natural process that happens regardless of what man is doing. Wind and the movement of water will take sand and soil, even small rocks. It'll move that off of the land into the body of water. It'll kind of flatten things out, just by the nature of it. So if you take away trees and vegetation, which have root systems that kind of hold all of the dirt and the sand and the rocks in place, if you take all of that out, obviously you're going to get more runoff. You're going to get more of the dirt and the sand and rocks taken away from the land and pushed into the water. When that happens, your turbidity usually increases. But we're going to experiment with that and find out if that's actually the case using that simulation. All right. So page 1.3, in the simulation that follows on the next page, you'll change the amount of vegetation along the stream, observe the effect on the turbidity of that water, and the number of organisms. So the population that inhabits this area of forest that live in this watershed. Since you will be removing and adding mostly trees, this is called deforestation. Okay, we're not really going to be adding many trees. We're mostly going to be removing them. All right, so let's see what happens here. Beautiful forest, nice trees. We got some little birds up here. It looks like there's some fish in the stream. The land is present here, and you can see that water would flow down the land into the stream. So what we're going to do is just we're going to click here, and you'll notice I'm going to click back to 0%. No deforestation has happened yet, but watch the trees over here. When I click it to 10%, you notice one of the trees disappear, just a little stub remaining. And I'm going to keep increasing this and just kind of watch what happens to this watershed. All right, we have one little tree remaining. Sad, it's now gone as well. So full, complete deforestation of this land. It's hard to tell the difference between the banks of the river or the stream and the actual stream itself. They're a lot of the same color of brown from the deforestation. Okay, so that was sad. Let me just back it up a little bit so you can see what it used to look like. And I'm going to quickly wipe out all of the trees. The wildlife, they have nowhere to live now. The fish can't live in a dirty stream. It's a very sad situation. And so we're going to answer some questions based on what you've seen here in this scenario. Okay, so let's go to this next page, and what we see is deforestation, sort of a percentage that we were clicking through before, and so 10% and so on. And the population numbers, notice what happens. So those are going down. As the deforestation percentage increases, the population decreases. And from the point of view of turbidity, how cloudy is that water? Well, the higher the number, the cloudier the water. Okay, so we started at 5, went to 50, then 95, 140, and you can see it's getting pretty darn cloudy there. It's 455. And then what happens is a graph has been created to sort of give you a visual indicator of what's going on here. And so you can see the graph is moving up when we look at turbidity versus the amount of deforestation. We can also look at population. Let's see what happens with population. Oh, that's interesting. And then finally, we can look at, oh no, I'm sorry, we can go back to turbidity. Let's leave it here for now and go to the next question. So page 1.7, what happens to the turbidity of the stream as a percent of deforestation increases? And our options are, well, turbidity increases, B, turbidity decreases, or C, turbidity stays the same. So we're looking at what happens to turbidity as a stream of the stream as a percent of deforestation increases. All right, well, let's go back to our graph and let's take a look. So as turbidity increases, as deforestation increases, we notice that our turbidity also goes up. So as one goes up, the other goes up. And so turbidity is dependent upon how much forest is left. As you lose trees and you lose those root systems, that soil becomes loose. And whenever there's some wind or water erosion, that dirt that's loose, that loose dirt gets pushed into the body of water, increasing the turbidity of that water. So turbidity is a nice measurement we can use to find out how much erosion is happening around that watershed. Going back, the answer here is increase. As the deforestation increases, so does the turbidity. Okay, page 1.8. Is there a positive correlation or an inverse relationship between deforestation and the turbidity of the water? Explain your reasoning. So this question is using some terms you may not be familiar with, so I'm going to explain those. So a positive correlation means that basically when one variable or one thing that you're looking at increases, another variable increases also. And conversely, when one thing decreases, the other thing also decreases. That would be a positive correlation. That's opposite, or I shouldn't say opposite, it's different than an inverse relationship. An inverse relationship means that as one thing increases, the other thing decreases, or vice versa. Okay, so we're trying to see, is there a positive correlation between the percent of deforestation and the turbidity of water? And so let's go back to the graph and take a peek. Well, we see here that as deforestation increases, so does turbidity. So turbidity also increases. So in that case, we would say that this is a positive correlation. These two things kind of mirror one another. When one goes up, the other one goes up also. And so that's what's going on there. Well, in addition, I need to also let you know a positive correlation in this case also means that look, the data is forming a straight line, so there isn't a curve to the data. It's a straight line from one to the other. So that means that they're going up at the same rate. That means they're going up at a constant rate. So that's why the relationship is a positive correlation. Okay. So in science, that's really important that you understand those terms because when you do your own research, you need to be able to explain the results that you've seen. And so sometimes your results may show a positive correlation, sometimes they may show an inverse relationship, and sometimes they may be inconclusive. There's no clear relationship at all between the things that you're measuring. All right, page 1.9. Based on your qualitative observations, what was happening to the stream banks as the percent of deforestation increased? So here's another term that we use in science. So we have qualitative observations, and depending on what study you're doing, you may also have quantitative observations. So a qualitative observation means that yes, there may be numbers involved in measurements, but really we're looking at something that we're looking at a process that's happening that you can pretty much describe without necessarily having a lot of data. And so in this case, a qualitative observation would be that, hey, you know what, when I start cutting all the trees down, I notice that the water gets super cloudy. A lot of the vegetation's lost along the shore. There's a lot of loose dirt here. So that's a qualitative observation. I'm not necessarily measuring everything, in detail, but I'm noticing that there is a relationship that's happening. Okay, so I would answer this question by saying the stream banks were eroding as the percent of deforestation increased. More water could be seen, and there was less green ground cover and more brown dirt. So that would be a perfectly good answer if someone asks you for a qualitative observation. You're describing what's happening in the process. All right, here's another graph. This is population versus deforestation. So this is looking at all the animals that are around or used to be around. And so as my deforestation increases, look what happens to my population numbers. They decrease. And so there's some questions related to that. Page 11, what happens to the populations of living things in this stream's watershed as a percent of deforestation increases? Well, does the population increase? Well, no, we saw that it's going down, not up. The graph shows that it's decreasing. We also saw that in the simulation. Population decreases. Yeah, that sounds pretty good. And then, or C, population stays the same. It's always important to kind of look at all the answers to make sure you're choosing the best answer anytime you're doing an assessment or answering questions. So in this case, B is the best answer. The population decreases. And finally, page 12, is there a positive correlation or an inverse relationship between deforestation and the habitat's populations? So all the birds and the fish and other critters that were around there, they sort of vanished as deforestation increased, our population decreased. So we would say this is an inverse relationship between deforestation and the habitat populations. So as deforestation increases, the populations decrease, and on the graph you can see that the data goes from left to right, from the top left to the bottom right, and so that's another indication that this is an inverse relationship. All right. Okay, that's it for this activity. Please check us out for some other video lessons that we always use files from TI-Nspire.com. Again, you can get that software from to run those files. You can get the software from education.ti.com. Check out more videos on our YouTube channel at TI Calculators, which is all one word, and look forward to seeing you next time. Thanks very much.